because I have a few things to say about this. So you had to find f of 0. Remember I said f of 0 gives me which intercept? That's the y-intercept. Okay, so that's easy. For 29, this first one up here, I guess I would compute that f of 0 is -6. And how about this other one? Let me call this one g of x so you can tell which ones I'm talking about. Okay? So g of x is going to be x cubed minus x. So then what is g of 0? Isn't that easy? I mean, finding where 0 is the input, finding the y-intercept is easy. Finding the x-intercept can be a little more work. Okay? So let's see. Now we want to find the zeros. That's my vocab word of the day, huh? The zeros, which are the x-intercepts. You know, one of the reasons they don't use x-intercept anymore is because some of the functions, like someone was showing me one, it said f of t. Well, then t's your input, right? So they just say zeros. Okay, so what do we do here? Well, the equation you want to solve is 0 equals 2x squared minus 6. Is this okay? You got to solve that. Okay, so here we go. 2x squared equals 6. X squared equals 3. So, what do I get? Oh, what do I do to both sides here? But when I take the square root, I need to remember that I'm going to get two solutions. Plus or minus the square root of 3. Okay? Those are both solutions. So by the way, if you were going to sketch a graph of this guy, can you name some points that are on the graph that are important points? Name them. Shout it out. 0, -6 was the first one we found. That was from finding f of 0. What else? Now, square root of 3 is where? 1 point something, between 1 and 2, right? So it's around here maybe. And then there's another one, negative square root of 3 over 0 is also a point. Okay? So there's a difference between the first parabola and the second parabola that I'm going to talk about in a little bit. Okay? I'm going to talk about in a little bit. And it has to do with what's called symmetry. Symmetry is something the book talked about in the very first section. And we did it for homework, and I never commented on it. People didn't really ask about it. But I want to make a bigger deal of it today. Okay. By the way, this one, when you want to find the zeros, let's see. So for g of x, I get 0 equals x cubed minus x. So what do? Well, you factor out an x. And then hopefully you know how to factor x squared minus 1. Do you guys remember how to do that? Yeah, that's called a difference of squares. My intermediate algebra class, this is exactly what we're doing right now, is all this factoring. And so we get, how many solutions here? 3 solutions, right? You get x equals 0, or x equals -1, or x equals +1. Okay, so now if I were to sketch the graph for g of x, what would that look like? Well, I'm not sure you would know. But I will say this, okay? You know that 0, 0 is a point, and what else do you know? -1, 0 is a point, and you know that 1, 0 is a point, okay? Now, I'm not sure what else you know about that function, right? So I went ahead and I graphed it. Do you guys see the 3 zeros we were talking about? You guys see what I'm talking about? Let me go ahead and graph in green the other one we did. We just did, what was it? 2x squared minus 6. And it should have how many zeros? Well, 2 different zeros, that square root of 3 and negative square root of 3. And let's graph that guy. So there's that one, right? The green one. That's hard to see. Can you guys see that? Okay. So it's between 1 and 2, like you guys said. Okay? And then I may as well graph the first one we did. The first one we did was x squared minus x minus 12. Okay? And let's graph that one. That one's going to be in red. So there's the first one. It's a parabola. The second one is the green one. And the third one is a cubic equation. It has those humps. All right? Now, the next thing I want to talk about has to do with these pictures, but it also has to do with tonight's homework. Okay? It's a concept that we talk about. Let's go back to the notes. We talk about what are called even and odd functions. Even and odd functions. So one thing that's on the homework tonight is zeros. You guys know how to do that. The next thing that's on the homework is they're going to ask you, is the function even or odd or neither? Now, for now, it may be a little mysterious to you why they call the function even or odd. I mean, you guys know what even and odd numbers are. By the way, quick show of hands, people that have heard that before, even and odd functions. Can I see a show of hands? So if you've never seen this before, here's what I want you to think of first. When we say even, what I'm talking about geometrically is symmetric with respect to, by the way, people that have seen this, you can shout it out if you know. Respect to what? The y-axis. Even is going to mean symmetric with respect to the y-axis. And I'll show you what I mean. Let's look at the pictures of the graphs we just did. I have 3 different colors of graphs. Can you tell me which one of these looks symmetric with respect to the y-axis? Is it blue, green, or red? The green one. When we say symmetric, what's that mean? It means if that y-axis were like a spindle or something, and you were to spin it around that y-axis, do you see how the green one would match up perfectly where it is? As a matter of fact, you might remember what those 2 points were. Square root of 3 and negative square root of 3. And notice it does that for the whole curve. You guys see that? That's even. Now, odd is different. Okay? Odd functions are, and let me do this in red, odd functions are symmetric with respect, oh, I shouldn't have done it in red. What should I have done it in? Blue. To the x-axis, no, not to the x-axis. Symmetric with respect to the origin. You can't be symmetric to the x-axis or you're not a function. But what do I mean by that? Well, let's look at a picture of that. And the reason I say blue is the blue function is an example of an odd function. You see that blue curve? When I say origin, what point am I talking about? 0, 0. Well, you have to imagine that I put a nail right into 0, 0. And I spun my piece of graph paper. I can't do this with my computer, but you can do it with your screen or your calculator. Spin it 180 degrees. Would the blue curve match up upon itself? And the answer is yes. And that means symmetric with respect to the origin. Do you see what I'm talking about? Who does? That's not universal. Let me try this one. It's really nice to understand it geometrically. But what also has to happen is we have to be able to do it without a graphing calculator. That's what Barbara just saying. Are we going to have a calculator on the test? No. Or not only that, the calculator gives me an idea if it might be even or odd, but it doesn't really prove it. What if it just missed the origin a little bit? Or what if it was 1.7 on this side and negative 1.6 on that side? Things like that. So you need a proof. So in order to do that, let me give you one more definition of even. Okay? So here's what I'm going to say. I'm going to say a function is even if f of x, no, let me say it this way. F of negative x equals f of x. And we've practiced putting other inputs in besides x before. So as an example, well, the one that we said was even was the function f of x equals 2x squared minus 6. And I'm going to say that this is even because, now, what do I have to show? I have to show that if I take f of negative x, that I get the same thing as f of x. So what's f of negative x? Well, it's 2 negative x squared minus 6. But what's that equal? Do you guys see how that's going to equal the same thing? Because what's negative x squared? Isn't that the same as x squared? Right? Which is f of x now. Do you guys see how that works? Okay? But think about the first example we did. We looked at this problem, and I'll do this over on the side. F of x equals, now let me think what it was. It was x squared minus x minus 12. You guys remember that example? So let's suppose I did f of negative x for this one. Well, I would get negative x squared minus negative x minus 12, right? And now I'm going to simplify. Well, what's negative x when I square it? X squared. What do I do here? Well, negative negative gives me positive x minus 12. And what do you notice? Those are not the same. That does not equal f of x, right? Right here's your problem. You got a minus x up top, you got a plus x on the bottom. That does not equal f of x. So we would say this function is not even. Okay, it's not even. Now, one more definition to give you. I want to talk about odd. So I'll write that here. We're going to say a function is odd if f of negative x equals, well, the answer is, remember, this is going to have to be symmetric with respect to the origin. And so what you want to say is, if f of negative x ends up equaling negative f of x, then we call that odd. That turns out to be the same as flipping it 180 degrees around the origin. Okay? So I'll do an example again. What was our odd function we had an example of? Let's see. F of x equals what? X cubed minus x. That was it. So we're going to say f of x equals x cubed minus x. This is odd because why? Well, what do I have to check? What do you think I'm going to put in for the input? You guys see this? What are we going to put in? Negative x. Okay? By the way, just quick comment. As I do these exercises in front of you, it's fine and dandy. And what you really want to do is you want to try and do them. I see a lot of people writing this out. But you want to try and do the exercises as I do them, or if you can even do it before I do it. That's the best. It's the way to get through college algebra. There's so much material in these sections. I try to do what's hard Okay? I try to have you read in advance. If you read this in advance, I'm not sure you would have got it from the reading. But maybe with this you can. I don't know. Go back to what we're doing. F of negative x equals, so what do? I put a negative x in for x. And when you put in negative x, you want to have it all in parentheses. So it would look like this. Negative x cubed minus parentheses negative x. Now I want to simplify. Well, I notice when I see negative, negative, that makes what? So we're going to have a plus x here. What about over here? Well, when I take away the parentheses, is there a negative or no? Yeah, we'd have three negative signs, right? So we're going to be left with a negative x plus x. Negative x cubed plus x. And the question is, does that equal negative f of x? That's the question. Well, the answer is yes, because you can write that this equals negative. What would you be left with if you factored out a negative 1? X cubed minus x. You guys see that? So if you understand that, that's a good sign that we have an odd function here. You have to analyze f of negative x. What about that other example I had? F of x equals x squared minus x minus 12. Well, remember, I already computed, if you just go up here a little bit, I already computed f of negative x. We worked out after we simplified it that it is x squared plus x minus 12. Right? We worked that out already. And I would say that does not equal negative f of x. Okay? And since it doesn't equal, right? If you factor out a negative 1, you're not going to get back what you started with. I mean, you could try. But that right there is not what I started with if I factor out a negative 1. So I would say that f of x, this function, f of x, is not odd. Right? So that's one way that these are different than numbers. A function can be not even and not odd very easily. So I guess I'd say it's neither.